Today we're going to look at the math concept of estimation. You're going to estimate in problem solving when an actual answer is not needed for the problem. It usually clarifies that by saying the word about in the problem or approximately. The two strategies that we work on with estimation are compatible numbers and rounding. Compatible numbers are the same thing as friendly numbers. These are two numbers that work well together by bridging to 10 or making a 5. Either the numbers are already compatible by doing both of those things, or you can make them compatible by changing them to its closest estimate. In these examples of compatible numbers, 67 plus 33 would be considered compatible because 7 plus 3 in your ones place will bridge to 10 to make a group of 10. 74 plus 11 would be compatible because the 4 and the 1 in the ones place would make a group of 5, and 5s are usually easier to work with. The rounding strategy follows very specific rules. When you're rounding to the tens place, if you look in your ones place, if it's got 5 or more, you raise the score, which means you raise it to the higher but nearest place value, and 4 or less lets it rest at the tens place that it's at. So in our examples, 34, I would look to the ones place, and since that's a 4 or less, I'm going to let my tens value rest at 30. 45, since that's hard because it comes exactly in the middle of 40 and 50, you really need to rely on your rule that since there's a 5 or more in my ones place, you'd raise the score to the next tens place, which would make 45 into 50. When rounding to the hundreds place, you pretty much follow the same rule, except since you're rounding in the hundreds, you look to the tens. If you have 50 or more, you raise the score. 49 or less, you let it rest. In rounding, once you round the place value, all of your other numbers become zeros. So each time you round, your numbers should end in zeros. Now we're going to look at a problem that would have us estimate. We're going to also compare the two to see which one would be more reasonable, compatible numbers, or rounding. This problem says Peyton and Lauren were counting the number of times they could jump rope without messing up. Peyton counted 146 jumps and Lauren counted 82 jumps. Write a number sentence to show the best way to estimate the total number of jumps Peyton and Lauren had. Since I'm finding the total, I know that my number sentence would have 146 jumps for Peyton plus 82 jumps that Lauren did to find the total. In the first example, I'm going to use the strategy of rounding. In 146, I'm going to round to the hundreds place. I look at my hundreds value, but then I look to my tens and ones. I know my rule is that 50 or more, you raise the score. 49 or less, you let it rest. Since 46 is less than 49, I'm going to let my hundreds value rest at 100, and my other numbers become zeros. 82, I'm going to round to the nearest tens place. I will need to look to my ones place. My rule is 5 or more, raise the score. 4 or less, let it rest. And since 2 is less than 5, I'm going to again let my tens value rest at 80, with my other numbers becoming 0. Now my estimation using rounding would be 100 plus 80, which would equal 180 jumps. This time I'm going to use compatible numbers. The great thing about compatible numbers is that these are the numbers that make sense to you, the numbers that you find easiest to work with. We might not all have the same estimation, but as long as they're close, it's a correct response. My numbers are 146 plus 82. We talk about how if I was to make 146 change to 200, that wouldn't necessarily be the best estimation because that's changing the number quite a bit. I might see that 140 plus 80 is easy for me. I know that now I have 0 ones. 80 plus 40 would equal 120, so I have 20 tens, and the 100 plus the 100 that I have in my original number would make my answer 220. I might think it's easiest to work with 146 plus 84. I'm changing 82 to 84 because 6 and 4 in my ones place, I know bridge to 10, and that makes it easier for me. 6 plus 4 is 10. I write a 0 in my ones place. I now have 40 plus 80, which is 120, plus the 10 that I made when my ones bridged, which would be 30 tens, plus the 100 that had carried over from 40 plus 80, plus the 100 in the original would give me 230. I might change my numbers to 145 plus 85 because I think it's very easy to work with fives. 5 plus 5 in my ones place would get me a group of 10. 10 plus the 80 I have in my problem would be 90, plus the other 40 in my tens would be 130, which would leave me with 30 tens, and the 100 plus the original 100 equals 230. You might notice that we got the same answers with both of those compatible numbers, which is a great strategy. Remember, when working with compatible numbers, they're numbers that are easy for you to do. They don't necessarily need to end in a 0, as long as it's a close estimate. When I look at the values that we did with both strategies, with rounding, my answer became 180. With compatible numbers, I got either 220 or 230. My original problem was 146 plus 82. We really like to compare and see which one was our best estimate. In this case, to get to the 100 that I rounded to, I had to take away 46. In this case, I had to take away 2 for the 80. That might not be my best estimate because that's a lot of numbers that I had to take away. In my compatible one, 146 became 140, which is a difference of 6, and 82 became 80, which is a difference of 2. In my last example, 146 stayed the same, and 82 I just added 2. So that's probably my closest estimate. We don't talk about finding the actual answer because that really defeats the purpose of rounding. You don't want to solve for the actual answer and then round because in estimation, you really want to have a pretty good idea as to what your answer would be if you did decide to solve it.